Ever pondered over the process of how a CPU gets programmed before it slips into the heart of your computer? It's a fascinating journey, to say the least. Today, we'll unfold this intricate process, breaking it down into digestible steps. Firstly, it's important to note that a central processing unit, or CPU, often referred to as the brain of the computer, isn't programmed in the traditional sense. Rather, it's designed to understand and execute a set of instructions, known as machine codes. These machine codes form a language that the CPU comprehends, enabling it to perform operations. The journey begins with the creation of an instruction set architecture, or ISA. This is a contract of sorts between the software and the hardware. It outlines the machine language that the CPU will understand and the types of operations it will perform. The ISA is crafted by highly skilled architects who ensure it's robust yet flexible, efficient yet versatile. Next, the ISA is translated into a microarchitecture during the design phase. This is the blueprint of the CPU and describes how the ISA will be implemented. It involves the creation of data paths, control units, and memory hierarchies. This phase is a high-stakes game of balancing power, performance, and cost. Once the design is ready, it's time for fabrication. This is where the physical CPU is created in a semiconductor fabrication plant. Layers of silicon and other materials are etched onto a wafer to create the transistors that form the logic gates, which in turn form the circuits of the CPU. After fabrication, the CPUs are tested for defects. Any CPUs found to have faults are discarded, while the rest move on to packaging. Here, the CPUs are mounted onto a protective casing, which also provides the interface to communicate with the rest of the computer. Finally, the packaged CPUs are ready for shipping and installation into computers. Once installed, the CPU can read and execute the machine codes that programmers write, enabling the software to interact with the hardware. So, to summarize: 1. The CPU isn't programmed, but designed to understand a set of instructions known as machine codes. 2. The process begins with the creation of an instruction set architecture, or ISA. 1. The ISA is then translated into a microarchitecture, which is the blueprint of the CPU. 1. The design is then physically fabricated in a semiconductor plant. 1. The CPUs are then tested for defects, packaged, and finally shipped for installation. The journey of a CPU from an idea to a physical component that powers your computer is a testament to human ingenuity and technological advancement. Next time your computer whirs to life, remember the intricate process that makes it all possible.